All right, so I'm going to do this so you can just don't worry about it. All right, so we're going to try this and see how this works. It may backfire, but we'll see. We're talking about linear equations. So these are lines, so system of linear equations. System of linear equation means two or more lines. So we're going to look at two lines. Two lines can intersect three different ways. Intersect in one point. They do not intersect. They're parallel. Or they intersect an infinite number of points. The same line is what it amounts to. So we are trying to find out what type of system that we have. Sorry, I'm just trying to move this so it looks better. So each one of these types has a name. All right? So these are consistent. And parallel are inconsistent. So that's the first thing. All right? Then the two consistents, would have independent and dependent. So if we look at these two lines, let's take the inconsistent first. All right? Things that we know about a linear equation is that slope and y-intercept. Those are the two things. Y equals mx plus b. Two characteristics of a linear equation is the slope and the y-intercept. So if I look at this inconsistent system of equations, all right, the slopes are the same. That's the only way they're parallel. Same slope. The y-intercept, they would cross the y-intercept at different points. So different y-intercept. If I look at a consistent independent, if we notice, the slopes are not even the same. So different slopes. Doesn't matter what the y-intercept is, they're just different slopes. And then when we look at a consistent, we see it's the same line, so they have the same slope, same y-intercept. Same y-intercept. So these are our three different systems of linear equations. We're talking about two linear equations at the same time. When I'm solving system of linear equations, I am finding the point or points that will make both equations true. And you see that would be any point that is in common. If you see my consistent independent intersects at one point. So that means there is one solution. That is an x, y coordinate. There's only one solution that will make both systems true, and we'll see how this is going to work in just a few minutes. If I notice my inconsistent system, they don't intersect at all. So there's no point in common, so there is no solution. If you look at my consistent dependent, you notice that it intersects everywhere on that line, so there's an infinite number of solutions. So, consistent, independent, they intersect at one point. Inconsistent, do not intersect. Consistent, dependent, intersect in all the points. Consistent, independent, the slopes would be different. Inconsistent, they will have the same slope but different y-intercepts. Consistent, dependent, they will have the same slope, same y-intercept. Now, if I'm solving system of equations, which we're going to look at in a little bit, if I'm solving system of equations, I find out I get one solution. When I solve, I would get an x equals something and a y equals something. That's my x and y points. If I'm solving for an inconsistent, I would get a solution that would be 5 equals 3, which is false. false statement, so therefore it would be no solution. If I get a consistent dependent, I would get a true statement. 2 equals 2. Or 0 equals 0, which a lot of times would be 0 equals 0. So you would have a true, a independent, consistent dependent solution. All right, so those are the three types. We need to remember: consistent independent, inconsistent, consistent dependent. All right, what's the characteristic? Different slopes. If I have different slopes, then I know for sure that it's going to be a consistent independent. If I have the same slope, it could be one or the other. So I got to check my y-intercept. Different y-intercepts, inconsistent. Same y-intercept, dependent. So I know. There's different ways to write my answer. If I have one solution, I'm going to write my answer with the x and the y. If I have no solutions, then I'm just going to write no solution. If there's an infinitely many solutions, I would get infinitely many solutions. How could I tell when I'm solving? Well, if I get x equals something, y equals something, then I would have one solution, consistent, independent. If I get a statement that's false with no x and no y, then it will be false. Then it's no solution. If I get an infinite number of solutions, it would be a true statement. So let's see how we're going to use that. Okay? So 3 different ways. Intersects once, doesn't intersect, intersects everywhere. All right, so let's look at 4y minus 2x equals 6. 8y equals 4x minus 12. So the easiest way to be able to tell me what system I have, I got a system here at 2 equations. System is 2 or more equations. So I got a system of 2 equations is to solve for y, get it in slope-intercept form. Divide by 8. Nope, it's wrong. 3/2. And here, solve for y. Divide by 4. So when I notice here, I get 1/2, my slopes are the same, my slope is the number in front of my x. So my slopes are the same, m equals 1/2, m equals 1/2. My y-intercept is here is, sorry, this way plus, is negative 3/2, and my slope here is 3/2. So my slope is 1/2, y-intercept negative 3/2. My slope is 1/2, my y-intercept is 3/2. My slopes are the same, but my y-intercepts are different. So when my slopes are the same, my y-intercepts are different, then I have an inconsistent system. Lines are parallel. I have no solution. I would get a false statement. All the characteristics of an inconsistent system. Lines are parallel. There's no solution. There's no answer that would satisfy both equations. The statement that I would get if I was solving algebraically would be a false statement. All right, let's look at another one. X plus 3y equals 1. 4x plus y equals negative 3. All right, again, the best easy way to do this is solve for y. So I'm going to get 3y equals negative 2x plus 1. Y equals negative 2/3 x plus 1/3. Slope, negative 2/3. Y-intercept, 1/3. Same thing here. 4x plus y equals negative 3. Y equals negative 4x minus 3. Slope, -4, y-intercept, -3. But notice my slopes are not the same, so I have a consistent independent. Consistent independent. What does that mean? One solution, intersecting lines, and it would be considered an open statement. Anytime I get an x equals, y equals, is considered an open statement, not a true or false. So consistent independent, this is the main thing I'm looking for. What does that mean? I have one solution, the lines are intersecting, and it's an open statement that I will get. So another one. Let's look at, see, y equals 2x plus 3, or minus 3 rather. Y equals, or 6x minus 3y. 6x minus 3y equals 9. This one's already solved. My slope is 2, number in front of an x. My y-intercept is -3, the number by itself. Here, solve for y, -3y equals -6x plus 9, divide by -3, y equals 2x minus 3. My slope is 2. My y-intercept is -3. Slopes are the same, y-intercept's the same, so therefore I have a consistent dependent system of equations. What does that mean? Same line, infinite number of solutions, and I would see a true statement if I was solving. A true statement. So the first section, what we're trying to do, we're trying to determine if it's consistent, dependent, consistent, independent, inconsistent. Inconsistent, no solution. Independent, one solution. Dependent, many solutions. And that's what we're doing. If it's a inconsistent, slope's the same, different, y-intercept. A dependent, slope's the same, y-intercept. And a independent, different slopes. Doesn't matter what the y-intercept is, it's just different slopes. Okay? So that's the first section, determining the types of systems that we have. You have three choices: inconsistent, independent, and dependent. These two here are consistent. So you can write those as well. Okay? Now solving system of equations by graphing. All right, solving system of equations by graphing. I don't have you do this too much because it's not very accurate, especially seeing I don't let you use graph paper. I don't want you to use graph paper here. Just do it on your notebook paper. So again, to graph linear equations, we want it in slope-intercept form. Y equals x minus 2. Y equals -2x plus 7. Draw my graph. Alright, first one, my y-intercept is -2, so I'm going to cross at -2. And my slope is 1, so it's going to go up 1 and across 1, up 1 and across 1. Okay? My next one starts at 7. comes down 2 and across 1, down 2 and across 1, and down 2 and across 1. Alright, so when I look at that, because I don't have graph paper, because I don't use a ruler, it doesn't come accurate. So I look and guess. Alright, it looks like it crosses at this point here, which is 3, 1. I want to check. Put the 3, 1 and put 3 in. 3 minus 2 is 1? Yes. Put the 3 in. 3 times -2 is -6 plus 7 is 1. So yes. So my solution is 3, 1. And this is what I'm looking for. Solving by graphing. Do not want you to use a table. If they ask you to use a table, I do not want you to use a table. I just want you to graph. So another example. Y equals -x plus 3. And y equals 3/2 x minus 2. Again, alright, we just put it in slope-intercept form, which is already there. First one, my y-intercept is 3. Come down 1 and go across 3. So therefore, I'm going to come down, if I come down 3, I'm going to go across 3. So there's my line. Down 1 across 1, down 1 across 1, down 1 across 1. My next one is -2, starts at -2. And it goes up 3 across 2. 1, 2, 3, across 2. So here's my line here. Alright, so when I look at this, it looks like it crosses right there, which is 2, 1. Alright, so I'm taking a guess. So this is why it's kind of inaccurate, so I don't like solving by graphing if we can. Alright, so, but if I put 2 in, -2 plus 3 is 1, so that works. Put 2 in here, 2 times 3/2 is 3, minus 2 is 1, so that works. So this is my solution. So solving by graphing, all we're doing is graphing 2 equations. Alright, you gotta remember graphing linear equations. Let's look at another one. Alright, so here there's not in slope-intercept form, so let's put it in slope-intercept form. Y equals -3x plus 5, and we get -y equals -x plus 7. Get rid of the negative, y equals x minus 7. Alright, so let's look at the first one here. My y-intercept is 5. I come down 3 and across 1. 1, 2, 3. 1 to the, oops, went the wrong way. 1, 2, 3 across 1. 1, 2, 3 across 1. So there's my line. Start at -7. Okay? If I go up, my slope is 1, 1 to 1, so if I come up 7 and go across 7, there's my line there. So there's my point. When I look at this, it looks like 1, 2, 3, 4, -4, 1, 2, 3, -4, I'm sorry, 3, -4. That's what it looks like. So I want to check that out, put 3 in. 3 minus 7 is -4. Put 3 in, -9 plus 5 is -4. So that is my answer. So -3, -4 is my solution. So I should see the graph, I should see the solution, and That's how we solve by graphing. So I don't have you do it that much, but there is some times for you to solve by graphing. So we need to know how to graph. The next method is substitution. Exactly what it says. We're going to substitute. So we're going to look at these. Look at an example here. T equals 2r plus 3. And 5r minus 4t equals 6. Okay, so substitution. I am looking for a variable without coefficient. Alright, so when I look at that, I see t here does not have a coefficient with it. So that's what I'm going to solve for that. Solve for that variable. If you have more than one, you have your choice. But if there's only one, that's the only one we're going to pick. We have one. We're going to substitute that value for the variable in other equation. So t equals 2r plus 3, so I'm going to take the 2r plus 3 and put it in for the r. I'm sorry, not the r, for the t. Almost messed you up there. So we have 5r minus 4 times 2r plus 3 equals 6. So the result here is going to be that we don't have a t anymore. We just have the r. And then we're going to solve. 5r minus 8r. Remember, this minus sign distributes. That's your common mistake. Minus 12 equals 6. Negative 3r equals 18. R equals negative 6. Once we solve, substitute value and beginning equation. Always alternating equation, going back and forth, back and forth. Never substitute in the same equation 2 times in a row. So we're going to put negative 6 back into here. So t equals 2 times negative 6 plus 3 is negative 12 plus 3, which equals negative 9. We're going to have different values between x and y. Just put it in alphabetical order. RT, so r goes first, negative 6. T goes next, negative 9. Answer. Check your answer just to make sure. Negative 6 times 2 is negative 12, times 3 is negative 9. Put it in here. Negative 6 times 5 is negative 30. Negative 9 times negative 4 is 36. Negative 30 plus 36 is 6. So it works. This is my answer. You should always know if you have your answer correct, because you can always check your answer and see if it works. All right, the next example. Let's look at another example here of, let's do that by this one. X plus 6y equals 2. Five x plus 4y equals 36. All right, so we're going to find the variable that does not have a coefficient. It's the x. Solve for the x. X equals 2 minus 6y. We're going to take that value, substitute it in for the x, and the other equation. So now we get 5 times 2 minus 6x, or 6y, plus 4y equals 36. If we do it right, then there should not be an x left. Multiply. Solve. 1. We're going to take that value and substitute it back into the equation you used first. Alright? So if you're confident that you solved this equation right, you can put it in this one. But if not, you can put it back into the original. Let's put it back in the original. X plus 6y equals 2. So we're going to put negative 1 in for y. So that's x minus 6 equals 2. X equals 8. So my equation would be 8, or my solution would be 8, negative 1. Always check it out. 40 minus 4, 36. 8 minus 6 equals 2. I know my answer is correct. Substitution. Let's do one more. Find the one I want to do. Let's see. X plus 12y equals 68. X equals 8. Y minus 12. All right, so here's already solved for an x, so we just use this one. I'm going to take this value, put it in for the x. 8y minus 12 plus 12y equals 68. Simplify, that's 20y equals 80. Y equals 4. Substitute the 4 back into the y. X equals 8 times 4 minus 12. So x equals 32 minus 12, which equals 20. Always put it in ordered pair form. X first, y second. 24 is my answer. 20 dash comma 4 is my answer. Okay? Let's look at another one here. Don't go with that one. That one. That one. 9a minus 3d. Equals 3. And negative 3a plus d equals -1. Solving by substitution. Again, I want to solve for a variable that does not have a coefficient. The only one is d. Solve for d. d equals 3a minus 1. All right, Caleb, you can go. Caleb, you can go. All right, real quick here. If I put 3a minus 1 back in the second equation, that's 9a minus 3 times 3a minus 1 equals 30. So 9a minus 9a minus 3 equals 3. That gets that down to, so that should be a plus, and minus sign distributes. So 3 equals 3. There's no x, there's no y, so therefore it's a true statement. So that means it's an infinite number of solutions. An infinite number of solutions. Okay? So solving by substitution. Solving by substitution. Alright, so we're going to stop there. We'll do elimination when I get back on Monday. So there's the determining the types of systems I have, solving by substitutions. And I'll have an assignment for you to do over the weekend. So hopefully you understand that, and we'll look at it some more when I get back on Monday.